Hello everyone, Ramya, Assistant Professor of CSE Department from Rohini College of Engineering and Technology, subject code CS3352, Foundations of Data Science, Unit 2, topic Describing Data with Graphs. Data can be described easily and concisely with the aid of a well constructed frequency distribution, and data can often be described even more widely by converting frequency distribution into graphs. Graphs for quantitative data. In that, first we are going to see the histograms. Here, a bar type for quantitative data. The common boundaries between adjacent bars emphasize the continuity of the data. As with continuous variables, a histogram is a display of statistical information that uses rectangles to show the frequency of data items in successive numerical intervals of equal size. Now we are going to see some features of histograms. Equal units along the horizontal axis reflect the various class intervals of the frequency distribution. Each units along the vertical axis reflect increases the frequency. The intersection of the two axes defines the origin at which both numerical scales equal 0. That means numerical scales always increase from left to right along the horizontal axis and from bottom to top along the vertical axis. Here the adjacent bars in a histogram have common boundaries that emphasize the continuity of quantitative data for continuous variables. The introduction of gaps between adjacent bars would suggest an artificial distribution in the data more appropriate for discrete quantitative variables or for qualitative variables. The next one is frequency polygon. An important variation on a histogram is the frequency polygon or line graph. Frequency polygons may be constructed directly from frequency distributions. Using this graph, we can follow some step-by-step transformation of a histogram into a frequency polygon. That means first, it shows the histogram for the weight distribution. Place dots at the midpoints of each bar top or in the absence of bar tops at midpoints for classes on the horizontal axis, and it will connect them with the straight lines. First, extend the upper tail to the midpoint of the first unoccupied class on the upper flank of the histogram. Finally, erase all of the histogram bars, leaving only the frequency polygon. The next one is stem and leaf displays. It is one of the technique for summarizing quantitative data is a stem and leaf display. Stem and leaf displays are ideal for summarizing the distributions such as that for weight data without describing the identities of individual observations. Constructing stem and leaf display means the leftmost panel of first, it recreate the weights to construct the stem and leaf display for the table. Next, we are going to see the typical shapes. That means whether expressed as a histogram, a frequency polygon or a stem and leaf display, an important characteristic of a frequency distribution in its shape. That means it is one of the equal segments along the horizontal axis are allocated to the different words or classes that appear in the frequency distribution for qualitative data. The next one is a graph for qualitative data. A person's answer to the question, do you have a Facebook profile, is either yes or no, not some impossible intermediate values such as 40% yes and 60% no. Likewise, equal segments along the vertical axis reflect increases in frequency. The body of the bar graph consists of a series of bars whose heights reflect the frequencies for the various words or class. Gaps are placed between adjacent bars of bar graph to emphasize the discontinuous nature of qualitative data. The next one is misleading graphs. That means here the graphs can be constructed in an unscrupulous manner to support a particular point of view. Popularly say including numbers do not lie, but statistics do. And there are three kinds of lies, demand lies and statistics. Thank you.